We may finish this section today, but I was planning on also spending tomorrow on it, so we'll just see where we're at. Just because there's not like a ton of examples, because there's not like a ton in this section, but find the points of continuity and the points of discontinuity of the function. Identify each type if it has any. So number 2, y equals x plus 1 over x squared minus 4x plus 3.
You know, 2 is the best number because it's the only even one in its prime.
You just said it's the only even one, like 2's the only even number?
It's the only even number in its prime.
In its prime, is that what you said? Oh, I thought you said and its prime, and I was like, well.
Like, can't you say best prime? I was very confused. What?
It's the only even prime number.
I know that.
Well, I guess it's the best even number.
Alright, to find points of discontinuity, set the denominator equal to 0. Sometimes you can also look at a graph and be able to see, but I mean, we need to be able to do it mathematically. So, x squared minus 4x plus 3 equals 0. What does that factor into?
Okay, so we have x minus 1 and x minus 3.
So, x equals,
1 or 3.
yep.
I don't know how I just wrote x equals 0 instead of x equals 3.
Now, at this point, you would probably need to graph them unless you kind of have an idea what this function looks like.
It's a no for me, Chief.
What's
Yeah.
1 over x squared look like?
Oh, I know
Yeah,
this.
wah, wah.
So what kind of discontinuity would that have?
Infinite.
But you can look at your graph and see it.
Yeah, but it's not just kind of a regular form because it has 2 discontinuities. This is dry. No,
You're
that's
right.
convenient. I already have an x minus 1, so I can make that a plus 1. It's x squared minus 4x plus 3. So 6 because that's the only one root. Wee. Graph goes here. Wee.
Whoa,
What?
that middle one.
What middle one?
I think that's one of my old ones. I still
Let
have
me see.
stats blood on.
Oh, those dots.
Well, yeah, that's the stats blood. So how do you know that it's infinite discontinuity?
Girl.
Because like it just, well, I didn't graph it, but it just like keeps going.
Okay.
There's like, essentially it's like an asymptote
Okay.
that's occurred a vertical asymptote.
And pretty much saying that like it keeps going on each side at x equals 1 and x equals 3.
Yeah.
So,
Basically, like there's 2 vertical asymptotes, and so if there's asymptotes, essentially there has to be infinite discontinuity.
Okay.
that's a really good way of thinking. You gotta remember that, Virginia. Just remember that the infinite discontinuity is basically just like vertical asymptotes.
I'm trying to.
You got this, I believe.
For absolute value of x minus 1.
I like that.
Oh wait, I guess I should put y equals.
Y equals absolute value of 1. I'll take that one. That's a good one. Are we allowed to graph that one? Yeah.
Do we need to?
No.
What is it?
It's just absolute values.
So are there any points of discontinuity of an absolute value function?
Nah. just wanna
Nope,
see what it
because
is.
it's just a V and it keeps going, so there are none.
It looks kind of wide.
I know, that's what I was thinking.
Virginia, can you look at like 23 and 24 and 2.3? Then look at like 43 and 44 and 2.1. Look at those graphs. Tell me if they look the same to you.
Which one's in 2.2?
2.1. 43 and 44. Huh. Fascinating. I don't know how I feel about that.
Okay. I was checking something to verify that my answer was right because the book's not this one, a later problem we're gonna do. Okay. Let's see. 6. Y equals the cube root of 2x minus 1.
I'll educate this from Virginia.
What does a cube root graph look like?
Well, I know what a cube one looks like. Cube one.
You can graph it if you need to.
Mayhaps a QB function turned on its side.
So I was gonna say I'm pretty sure that it's something like that. Not a line.
Gotta be fast.
Something like that, but I could be wrong.
Yeah, I think that's.
And obviously shifted because of that 2x minus 1, but
2x minus
Is on its side.
is that right? Approximately? Okay. So, are there any points of discontinuity here?
Yes.
None.
Mm.
8. We're gonna get a little crazy here.
Uh,
Y equals the cotangent of x.
oh, nice.
Oh, 0, right? It doesn't cross through 0.
Yeah, that's one of them. And
What
we have,
else?
It goes
Like pi
between.
over 2
Yeah.
plus or minus pi over 2 plus or minus. Is it all of those or?
So where would
No, it
where
doesn't.
would tangent have a problem in the denominator? Increments of what?
Pi, right? Pi.
Increments of pi.
Pi. Love pi. Pi is tasty.
So we would have asymptotes at increments of pi because the cotangent graph looks something like this, I do believe. So this would have an infinite discontinuity, or infinite discontinuities, plural, at x equals k pi, so any increment of pi essentially is what that's telling us, where k can be any number, or any integer, I guess I should say. Because it would also be at negative pi and so on and so forth. And it's infinite because it keeps on going.
Do you think they're alright?
One can hope so. I'm checking one more thing to see if I want to do this other problem.
The upside down A means like at all, right?
For all, yeah.
So how did this thing break in the first place? People just too rough with it.
I think so. I'm not really sure.
Cause I mean, I've been trying to be kinda gentle with it. Like if it's not gonna go, I mean, I'll try just a little.
Yeah, I
harder.
think people were just turning it till it
Trying to
to like get it into place,
Like, I mean,
to get it where they wanted it to go, which I think is what threw it off.
yeah.
I'll try a little harder, see if.
There
maybe
was
it
one
just
that was
stuck.
like it was just stuck that I was trying to turn it yesterday because I like would look and see. Okay, I'm gonna do 10 and then I'm gonna backtrack to 7 because I want us to see something about 7.
Ooh, that's an odd one.
It is. It's also very prime.
Mm.
All right, 10 y equals the ln of x plus 1.
What was that, Virginia?
You only knock on wood if I get
Well, it was just for good measure. I'll take that.
that actually cancels out your jinx. That means I get it. And then you know.
Oh, now I don't carry dollars.
Fine. 20 would be fine, I guess.
No. I'm not gonna let you cheat me out of that much money.
So does this have any points of discontinuity?
Sure.
I'm gonna say no. Just
I mean, maybe not in its domain, but
What can't be in the domain of a logarithm?
negative.
No negative numbers.
But I mean, I guess x could go to -1, but that's as far as it goes.
Right, because it can be 0, right?
Mm-hmm.
But it can't be negative. So essentially, it's discontinuous at all points not in its domain.
That sounds kind of normal. You know.
So the domain would be x plus 1 is greater than or equal to 0. So x is greater than or equal to -1. So essentially, it's continuous as long as x is greater than or equal to -1. But it would be discontinuous less than that. This class gets out of 39, right?
Yeah.
Okay.
Goodness.
All right, I'm going to backtrack to 7 just for a second. Y equals the absolute value of x over x. Graph this one.
Okie dokie. Graph view. Ooh, I like that. Not really, but it's fascinating.
What happens?
It's
That's
just
not
at
the
negative.
zero.
It's just at -1, and then it just goes poof at 0, and then it goes to
It's like one
positive
of
1.
those like step ones.
Mm-hmm. So it goes until it hits 0, and then it jumps up, and then it starts going again. So, what kind of discontinuity is this, and where is it?
Jump discontinuity?
Yep.
I'm so glad I didn't say anything because I would have said a step discontinuity.
And where is it? We always say a discontinuity is at x equals something. Or like in this other one, greater than or equal to. So wherever that jump occurs, that's where it is. So x equals 0.
Always does.
Alright, let's see if we can do these. 12 has parts A, B, and C, or A, B, actually all the way through D.
Oh.
This is where you need your book. So 12 says, does f of 1 exist? So if I plug in 1, is there a value there?
Yes. Are you supposed to be looking at that graph?
Yes, the
Okay.
graph that's, over on the left.
Just making
Someone
sure.
wrote on it.
So yes, f of 1, what is f of 1?
1.
Yeah, you don't have to put that, I just am doing it for reference. Part B, does the limit as x approaches 1 of f of x exist?
Yeah. Yeah.
Yes,
Yeah.
because we have the two-sided limit.
So like if
As it's approaching 1, it doesn't have to be exactly equal to 1.
so if the limit on like both ends was different, then it would not exist.
Correct.
Okay.
Alright, then part C, does the limit as x approaches 1 of f of x equal f of 1? So what is the limit in part B?
2.
2.
It's 2. Are those two things equal?
No.
No.
Last time I checked, 1 and 2 are not equal.
1 is not equal to 2. Is f continuous at x equals 1?
You got this,
No.
Why not?
Because of like the whole.
Yep. What kind of discontinuity is that?
1 second. I got this. Removable.
Yep, removable. Alright, 14. At what values of x is f continuous?
From like -1 to like, well, it kind of doesn't continue at 0 anymore.
So it's from -1 to 3, except at
Seriously.
x equals 0, 1, and 2. And then part 16 really fast. Says, what new value should be assigned to f of 1 to make the function continuous at x equals 1? So basically, what did the limit equal? 2. So it needs to be equal to 2. Alright, we'll pick up tomorrow. There's only like 4 more problems that we're going to do with that, but they'll take a little bit more because it's a little bit more math involved than just like looking at a graph. So we should be able to finish tomorrow.